What's up, ladies and gentlemen, YouTube, everybody out there, it's Phil20, and I'm back. I'm going to show you guys, I'm doing some really interesting electricity stuff. Some people probably think it's stupid, but I'm shocking myself in here so you can actually see something that you may enjoy that's funny. So here it goes. Holy crap, that's 550 volts, yeah! Let's see here. I got an idea. Let's, here, if you can come around to this side, Maria. I'm gonna see if I can shock myself and spin it at the same time with my hand. Let's see, So remember that high voltage means it's more than 50 volts. So right here, I'm gonna touch it and you're gonna check the voltage on this side.
Okay.
Actually, you'll check it right here because this will be the connection. Either side doesn't matter. And this is alternating current voltage that's going into the bridge rectifier because this turns it into DC where you charge batteries with.
Okay. You want AC?
Yeah.
Okay.
So we're on AC. And oh, oof. 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 Gosh, oh gosh.
How many volts is that?
It's like 50 to 80, maybe 100.
Would that kill you?
No, because it won't kill me because it's going through my finger and back out my other finger. But I would not do it like this because it would go straight through my heart and change the rhythm, possibly kill me. But this is also DC current, so it takes more resistance to go through. This is AC current, so if I was to touch it on the AC side, it's really going to shock me really bad compared. So if I just barely turn it, I should be able to feel it even more. There's 24 volts. See, when it beeps, it's about 50 volts or so. So I can feel it. Ooh. Ooh, gosh, that was tough. Ooh. Yeah, that's a lot of power coming out of there. So what you're looking at is this transformer steps up the power, puts it into these other, and this one I measured it like 390. This one was like 490. This was like 600. I've seen almost the high speed was 600. And with a transformer, okay, ladies and gentlemen, yesterday you seen me make a wind turbine with a fin on the back. That's right, yes. I got something a little bit different here. I'm going to show you this. Now, this is kind of cool, and sure I'm not the first person to think about it, but I did want to think about this. Now this, I'm going to let you guys see the voltage alternating current coming out of it. So I'm spinning this free-handed, and let's switch to VAC. So I'm spinning it free-handed. There's 22, 19, 18 volts. So I'm spinning it freehand. We get pretty good voltage coming out of it. It's pretty good. It spins pretty easy when there's nothing hooked up to it. But I put a transformer in between this and a bridge rectifier. I want to show you how it behaves. So we get easily 22 volts, and then it spins pretty freely. So what I want to do next is to connect these wires to the secondary coil of a low voltage transformer. Now the secondary coil is going to be a much thicker wire and wrapped around much less times. It's probably wrapped 10-15 times at the most, I'd say this is wrapped around 15 times. No, wait, let's see. 2 times is 2.2 volts at 115 volts. So it's probably wrapped around 40 times, to be honest with you. Or 12. I'm not sure. And I don't know the math. I'd have to take it apart and count them. But I do know that it builds up magnetic fields inside this iron core. And then it sends it back through the other wires, which has a different coil in there. And it spikes the electricity out of it. Now I want to show you, since I hooked up those 2 wires, right, into that transformer, it's cogging now, okay? And it's cogging because it's got to send electricity through, and it has to push the electricity through on this now. So it has a really strong cog to it. Now, my assistant, my beautiful wife and sponsor of my YouTube channel, is going to help me by touching this to that. All right, so this is the DC output side. Remember, we've got 2 wires coming out of the 3-phase motor on 1 phase. And that goes through the transformer, and then it goes to, this is common. This is high voltage, 240. This is medium voltage, 208. And this is low voltage, 115. Okay, so if you wanted to hook up this to a 240 volt system, you'd hook up these 2 wires. And then if you want to hook up to a 208 volt system, you hook up these 2 wires. If you wanted to hook up to 115 volts, you'd hook up these 2 wires. So that would be your primary coil, but since we're reversing it, it's now our secondary coil because we reversed it. So what we're going to do is I'm going to show you, this is the high voltage circuit. When this beeps and the light turns on, that means there's more than 50 volts and it is now potentially dangerous. I'm going to take my hand and I'm going to spin this shaft with my hand. Okay, so it spins, it goes up more than 50 volts very easily, and I'm going to try to spin it. 95 volts there, I've seen it. 79. 66. There's voltage coming out of that, and that's DC voltage after the transformer. Now, what we're going to do again is we're going to hook up this thing on the drill, okay? And what we're going to do is we're going to test the voltage coming out of this. So if my wife would hold that, and I'm going to attempt to connect this in here with it and see what the voltage is going into the transformer. So we know we're getting a decent voltage coming out of the transformer, but with it connected, what's the voltage going into the transformer? And if I got it connected correctly, we'll check the voltage. You have to touch the metal, babe. There you go. So I'm spinning it like I was before. There's 12 volts, 5, 14, but we're not getting high voltage coming out of it. So this here is putting out a lot of power when we're only putting in 14, 15 volts. We're going to spin this up with the drill at the highest speed that we can get. So we're outputting 142 volts here, okay? And then we're stepping it up from 142 volts into this to 500, I bet you. Let's find out. Now, since it's coming out of this, 142 volts, we're stepping it up here we can connect the alternating current and check the voltage. Okay, and I'm going to use the drill at full speed. $722 volts was coming out of the thing. That is super dangerous. I'm not even supposed to connect 700 volts to this meter. If there's an electric company out there that wants to send me a very high voltage meter for me to demonstrate, you guys know, give me a comment below and we'll talk about getting that over here. But we still have this situation where we're making a ton of electricity. Now let's test the DC side of the power. We had 721 volts. So we got 407 volts output. So the efficiency here is pretty bad. It's not a very high efficiency. So when it goes through, we're not, oh wait, I did that wrong. We need to switch to direct current to test this specific situation. So again, so that's 550 volts, nearly 600 volts DC power coming out of the bridge rectifier. So this is not an application you could use in a grid tie system, but it's really cool. Now, for instance, I could build a different transformer that converts at a different rate, at a different voltage. Let's say we got 150 volts here, and I don't want it to be cogging. I can reverse it and reduce the power coming out. Now, I disconnected the transformer completely. I wire nutted these two connectors off. This was the 115 volt circuit. This was the 208 volt circuit. This is the 240 volt circuit, and this is the common circuit to all of them. So you can connect any one of these to test and reduce the voltage. So we're going to do this real quick. We're going to connect any of the three wires, because this is a three-phase motor. Here, those blue wires, those low voltage are getting in the way, but so. And look at that, we're matching orange with orange, which doesn't matter because it's alternating current. Unless, you know, it's the wrong wire to go there. Read the wire diagram. If you don't know it, you need to know it. So what I want to do is test the amp draw on this DC side and see if we can get some good current through it. I said DC side, I'm sorry. This is the low voltage side, but it's still alternating current, so it will show us amperage in alternating current. And we're going to connect our clamp meter, and we're going to connect this. So we're taking higher voltage, we're stepping it down 10 times with this set. So, and it spins easier right here, so it's so much easier to spin. And you can see as I spin it, I've got 0.2 was it 300 milliamps. I'm spinning at 400 milliamps. So I'm spinning it, I'm getting, you know, a half an amp with my hand. So I'm going to take this drill and I'm going to spin it up slowly. So we're going to spin it. So it's 1 amp, 3, 5 amps almost right there, just by changing the circuit itself. Now hopefully I didn't kill the transformer, because this thing is not designed to handle that many amps. Now we're going to check the voltage on this circuit coming out of it. So we're gonna check it, and like I said, we should be dropping 10 times. So it's a possibility that we're gonna be looking at 14 volts coming out this at alternating current. Now, I don't know how much it'll be, but I'm guessing it'll be 14. So I'm going to spin it free-handed, and we're at 2.3, 2.1. It is totally easy to spin. It's super easy to spin now. It's easy as pie. We're going to put it on the drill, and we're going to spin it. All right, so we got 17 volts coming out of that thing. And I'd say if you dropped it down to 14 volts, you'd be run through a bridge rectifier. You could charge a 12 volt battery with this setup and the transformer, and it would spin very easily, and you wouldn't have to worry about going too high of a voltage, because the resistance of the battery is going to probably pull it down to prevent overcharging. But you could still use a brake, but it wouldn't work as well with a transformer, resistive load, because the transformer itself is going to have a thinner wire and allow this to spin more freely. So, and it seems really cool. The idea is really cool. So instead of stepping it up, like I showed you, we got 600 volts, 700 and something, 771 volts out of this to that to this. That is so cool. But then we reversed it, and we got 17 volts out of this thing into this. And I haven't tested the DC side of it. Let's just go ahead and do one more test and check this on the DC side. So there's that. We won't need those two for the moment, and I'm going to move that just out of the way there. And I know I should be using terminals, but I'm testing stuff back and forth, so that's a good connection there. Now, we currently have the alternating current output of the transformer going straight over to here. And I believe we can actually increase the voltage by changing these, if I'm not mistaken. It might actually decrease it. Yeah, if we switch to these, it'll decrease it. So we'll test this one and then this one, and after we test the DC output. So we can really customize the voltages coming out pretty good. So if we can just check the DC side, remember we had 17 volts when we was turning at full speed, and I'm spinning it free-handedly. 2.2 volts. Okay, that's pretty good. Not too bad. Now, what we're going to do is we're going to put our drill back on there. Now we're going to spin it. So we have a much higher voltage drop coming out of this transformer. It was 6 volts, I believe. Oh, wait. We're on AC voltage. That's not correct. Now let's try again. So it's 15.6 volts. That is pretty cool. I think I might have a 12 volt lamp. I am absolutely not sure if this thing works, but Let's give it a try. What do you say? Oh, come on. Thank you. It's touching, but not touching the alternating current side. So let's spin it. That is so cool. So we're making electricity from this permanent magnet motor, putting it into the transformer, reducing the voltage quite a bit. Can we test the voltage of what this is when it's spinning with a 4 watt? This is a 4 watt lamp, I believe. So just check the voltage there. So it's 13.6 volts right there. 13.7 volts. So that's pretty cool. I'm pretty excited to show you guys this. Is a little trick that you can do with transformers. You can change the voltages. I really don't think it'd be a good idea to go ahead and go any lower than this. The way this is set up, it would not do a lot. But if we had 3 transformers running, 1, 2, 3, running all 3 circuits, because you know these 2 are a circuit, and then you can take this circuit to another circuit, and then that circuit to this circuit. So you'd have 3 circuits that you can put these transformers on, and then you can put those in parallel with single bridge rectifiers, and then you would have, like, I could put one here, and then one here, and then you parallel these with each other, and then you triple the power output, and it's still going to do pretty good. I can't light it up with my hand. Let me see. Oh, I'm lighting it up with my hand. That's so cool. This is Philip 20 with solar power, electricity, and electronics. Holler at y'all later. Peace. Hello, ladies and gentlemen. Thanks for watching all the way to the end of the video. There's lots more content coming. Click the subscribe button below. Make sure you come back for more, because there's great content always coming up every day in this channel. See you next time. Peace.